Okay, our next assignment is a real cool assignment, at least if you ask me. It's going to involve a few new concepts, so let's take a minute to talk about those new concepts before we go into the details of the assignment. As always, there is supplementary material in Canvas. And remember, given that this is a blended class, the expectation is that, instead of a second lecture, you review this material on your own and bring to me any questions that you might have. So week 5 to do this week. All right. First thing we're going to talk about is the Java Fetch API. This is a JavaScript and function. And it is an example of Ajax. What is Ajax? Ajax stands for Asynchronous JavaScript and XML. Now, we're not using XML here, but it doesn't matter. The main part of Ajax is the asynchronous JavaScript. What does asynchronous mean? Asynchronous means not at the same time. Those of you that are watching the lecture live are engaged in watching it synchronously. In other words, I'm speaking right now and you're hearing it right now. Those of you that are connected and listening live. Asynchronous means if you came back and watched the video later, we're not synced up. I am not speaking when you are watching it. So JavaScript Fetch API is a way to handle asynchronous data. And the way it works is like this, and this is why this is considered asynchronous. All right. In this case, we're pulling data from a file. We give the file name and we say fetch file. What it's going to do is it first does this instruction and it waits until it's done, and then it does this, and then it does that. So let's see what this does when we run this. Fetch a demo file. Am I supposed to have a file like this? I don't know. We'll see a better example to fetch later on. Why is this asynchronous? It's asynchronous because we're going to be talking to a web server. And when we're talking to a web server, that web server might not give us an immediate response. Typically, instructions in a JavaScript script run sequentially, one right after the other. First one finishes, second one runs, third one runs, fourth one runs, fifth one runs. If we're asking the server for something, we can't run the next instruction immediately. We have to wait for the server to respond, and then we can run what we want to do with the data. So in our case, we're going to be asking the server for some data. We're going to be asking the server for some weather data. When the server responds, then we're going to go and do something with that data. So this is asynchronous. This is an asynchronous call. These aren't really good examples on this page, but it does show the format for this. Next concept we're going to cover is JavaScript Objects. Now, those of you who have had other programming classes may be aware of objects. An object is a software representation of something that has properties and it can have methods. So for example, we could have a car object, and one of the properties is the car name. Another one is the car model. Third one is the weight of the car. The fourth one is the color of the car. That's different than a string. All right, if we had a string, we'd simply store the name of the car in the string, maybe. With an object, we're storing multiple values about this variable. So the car has a type of Fiat, a model number of 500, and a color of white. Notice this notation here. This is one of the other concepts we'll talk about, JSON, or JavaScript Object Notation. The way we represent objects in JavaScript is through this style. And this is a very simple example, and things can get more involved, and we'll look at a more involved one, where the values are name of the value, colon, value, comma, name of the value, colon, value, or the name of the property, value. So here, for example, we define an object, a person object, that has these characteristics. We can refer to stuff one of two ways. We can either say person dot last name, or we can say person and then in the square brackets last name. So that is JavaScript Objects. It's more about JSON, and it largely repeats a lot of the concepts that we had before. Lastly, and we use this word already, and when we talked about the JavaScript fetch, but we didn't define it, is an API. An API stands for Application Program Interface. It's a way that applications can talk to other applications. It's a way that two pieces of code can communicate with each other. And in our case, our code is going to be the JavaScript that we're going to have on a web page. The code that we're going to be talking to is going to be data on a web server about weather. We're not going to have all the weather of the entire world stored in our JavaScript code. That would be unrealistic and probably impossible to do. All right. Instead, we're going to ask a server for certain weather data, and the server is going to give it back. Now, it's asynchronous because when we ask for the data, we have to wait until the server responds. And then when the server responds, we can go and do our thing with the data. We can't immediately start processing the data because we don't know if the server responded. And again, that could be different on different days, right? If the web server is particularly busy, it might take us a little bit longer. If we have a slow internet connection, it might take a little bit longer, and so on. But an API is the way that these two things communicate with each other. And there's always two parts of an API: how you make the request and how you get the answer back. All right? So just sort of file that away in the back of your mind, and we'll look at a specific example when we cover the weather example. All right? We're going to see how to make the request and how to process the data that comes back. Now, in our case, the data that comes back is going to be in the form of a JavaScript object. So we need to know JavaScript object notation to be able to pull out the pieces of data we want. Because the weather is not simply one number, right? Associated with the weather is, is it cloudy or sunny? What's the high temperature of the day? What's the low temperature of the day? What's the current temperature? What are the chances that we're going to have rain? The direction and speed of the wind. All these things make up the weather, right? So the weather isn't one value. It's a collection of values. It's an object. And we're going to need to use JavaScript object notation to take and pull out the pieces of data that we're interested in it. So here's what we're going to do. Here's the example that we're going to modify, and we'll talk about how we're going to modify it after we've gone over it. So scroll down, go to this page, scroll down. There's a lot of nice little examples. Good way to learn this might be to go through some of these. We're going to go for the real-time weather app. One of the things that I was going to say focus group, I suppose it is a focus group, our advisory committee suggested that we cover in our programming classes is the use of APIs. So I introduced this in our class based on the feedback of our advisory committee, which is people from industries and so on. So link to the source code, go up here, download zip. All right, here we go. And if we go to our page, this page has the HTML, has a JavaScript and an external file. That'll be our first example of seeing that, I think. I've been putting the JavaScript within the same file, but just like with CSS, you can put it in its own file. Our HTML and our CSS. And then there's some icons and fonts and other stuff. So if we run this page, immediately we get asked, do we allow the page to know our location? There is protocol built into the JavaScript document object model that contains information about the location of the machine that's running this. Now that location can be precise or it can be approximate. For weather, I suppose it doesn't really matter that much, unless you're running through a proxy server or something. But your precise location would be if I was running this code on a phone that had a GPS. It would know exactly where I was. It would know that I am sitting in the middle of BU 103 on Lorain Community College's campus. If I'm not on a GPS enabled device, it will give us the location of the web server. And again, in this case, it's going to be also Illyria. So if we answer no, we get an error message. All right. I denied access to my location. And there's all kinds of reasons that you might want to deny your location on a page. And this location was considered important enough to force the page to ask permission before they access it. Let's call it up again. This time we're going to say allow. And boom, it comes up with a little icon that represents whether it's sunny or cloudy. So the sun is peeking through, but there are a lot of clouds, so it's cloudy. 17 degrees Celsius, and if we click on it, it shows us what that is in Fahrenheit. Gives us a verbal description of the weather conditions, overcast, clouds, and it gives us the location it has for us, Sheffield, USA. So again, that is not the location of my specific machine. That is the location of the server or the internet vendor that we're connected to, or internet service. Okay, pretty cool, huh? Now, again, our HTML page could not possibly have all the code in it. Even with JavaScript, could not possibly have all the code for everything in the world and their weather locations. So let's see how we do this. We do this by making a call to the server. And information about that API can be found here. Remember, with an API, you would give information about how to call the server and what you're going to get back. So in our case, and for this program right now, this is what the call looks like. It's actually a URL. Call this, and that's a request for a web page. And we specify the latitude and longitude, which we can get from the document object browser. And we must apply an API key. An API key is simply identifying who is using this. A lot of times, API services will be free for up to so many uses per day, and then they'll charge you something for it. So I'm going to give you the, do I give you the API key? Oh, I think they give you the API key to use, just to test this out. That's right, they give you the API key. I thought I had registered, that's another API. Anyhow, this is what we call. We make this call, which again, a call to a server typically is what? It's a request, which is represented by a URL. This is what we get back. JSON formatted data. Coordinates. Again, this is a more complicated example of JSON where each element isn't by itself just a single value, but it can have multiple values. So for example, the coordinates of the weather has a longitude and latitude. The weather itself has an ID, main description, or the main response, the icon that's going to be used, and so on down the line. All right, let's look at the code. Let's first start out looking at the HTML, which there's not tons there. All this is being done in JavaScript. So if we look at this, basic HTML, we have some divs that we're going to fill stuff in with. We have a notification div. We have a class of weather container. We have a class for weather icon. And all these things we can see correspond to stuff that is on the page. For example, that notification, when we weren't allowed to access it, that's the message that we got, was in that notification div. The icon is in the icon div. The weather description, temperature fits here. The description and the location. They're all initially blank. So if I were to get rid of the script, that's what we get. We get a blank, get a web page that has locations for us to put the data in. Our CSS styles it. Now, there's a couple of things that they do in this example that I don't like. And I'll cover those right away. There's always more than one way to do something. All right. And sometimes you can't really say which way is a better way to do it. You know, there's two alternative ways to get something done, but sometimes you can point to practices that are better. If you remember in the example I gave last time, I used an onload method. That invokes some JavaScript when the page finished loading. They don't do that. They simply put their JavaScript at the end of the page. So when the page is done loading, and we're at this point, it's going to pull in the JavaScript and execute it. It works. I think a cleaner way of doing it is to use the onload like we did last week. Likewise, they use classes for these things. Since there's only one thing on the page for each of these, there's only one temperature value, one temperature description, one location, and so on, I would have used IDs for them. Remember, you use an ID when there's only one instance of something on a page. You use a class when there's potentially multiple. Well, if we had multiple temperature values on this page, then our code's going to mess up, all right? Whereas with the ID, we know by definition that that needs to be unique. All right, on to the JavaScript. All right, there's actually a video that explains this, and I've posted that video in the links for this week.
Terra is the IT painkiller. Remote monitoring and management, remote access, help desk and ticketing.
Anyhow, you can find it here. You can go to this YouTube account and look for the weather application if you want to watch the video. I think it's still out there. I'll post a link after class. First thing we do is we load up all these constants. We find the things on the page that we're going to put our answer in, and we give them a name. So we use the query selector to find the things on a page that has the name of weather icon, that has a class of weather icon, has a class of temperature value and is a paragraph, or temperature description and is a paragraph. Both of those. Location is a paragraph and notification. So we're simply giving names to the different sections of the page. And this is where I would prefer to use an ID, because actually this code would mess up if you happen to have two things, if there are two paragraphs within temperature value. Whereas if you use the ID, you'd be safe. So what we're doing here is we're creating variables for the places that we're going to put stuff in our JavaScript. These are declared, notice, outside of any function, which makes it available to any of the functions in this JavaScript. So notice this code is not in a function. So these variables sometimes would be called global variables, which probably isn't a good term, but yeah, it's global to this page. We are global to the script tag. We can call it anywhere in the script tag. We create our weather object. Remember, our weather object is going to contain all of the relevant things that we're interested in the weather. And we start out by initializing our weather temperature sub-object to have a unit of Celsius. We have a constant of Kelvin. Kelvin is used as a temperature in scientific, used in science a lot. 0 in Kelvin is absolute 0, which means it doesn't get any colder than that. There's no negative Kelvin temperatures. And the Kelvin constant is, the Kelvin constant is 273 because to get centigrade temperature, you add 273 to the Kelvin. So for example, 0 centigrade would be 273 Kelvin. Here's our API key, which again, they give it to us and we can use it. All right. So far, nothing too drastic. I hope not anyhow. They used a query selector to find the things. Again, I would suggest using get element by ID. They create a temperature object that they give some values to, initialize a couple of variables that they're going to use. All right, the next thing is check to see if the browser supports geolocation. Now, this probably was written a while ago, this code, because virtually all browsers support geolocation. All right. I don't know when that came into play, certain revision of browsers. I mean, we could Google it, but it's been a while since geolocation has been part of the document object model. So this is seeing, is geolocation available in this particular browser? And it's either yes or no. All right. If it's not available, it performs this code, which is going to put in a notification element, set the style to the display of block, and set the inner HTML to browser doesn't support geolocation. I probably can't even show you this code because I'd have to download a very old browser to do that, and I don't want to spend the time doing that. Now, if geolocation is enabled, I go and I call get current position. All right. Get current position is going to do a few things. Or a few things, let me put it this way. A few things happen as a result of this command. First of all, because we're asking for the permission, because we're asking for the position rather, the browser is going to ask us for permission to know our location. If you remember and you saw that when we went to that page, it asked us, hey, do you want to allow the browser access to your location? This is a command that did it. If we answer no to that, we call the show error function. Or if there's some other issue with the geolocation service. So if there's a problem, such as we deny permission or there's some other unforeseen problem, this function is going to get called and it's going to pass in an error string and we're going to display that. Otherwise, we're going to get back from this get current position. We're going to call this function. Whoops. We're going to call this function set position, and we're going to give it automatically. This happens. That function is going to get the position, and that position contains a number of things. The two that we're interested in for the API is the latitude and longitude. Do you remember back when we looked at the API? We saw that to make this call, we needed to know three things. We needed to know the latitude, the longitude, and the API key. Well, we define the API key up here. This is going to give us the latitude and longitude. Then we call this function getWeather that actually does the work of calling the API, the weather API, and then displaying the results. So getWeather creates a long string for the API call. Remember, there's a request and a response. This is how the request is formatted. This hard-coded string with the latitude, longitude, and the API key inserted in it. We fetch the API. That is going to make the call to the server and is going to wait until the server responds. And if the server responds, it does this little function of taking the response it got from the API and actually make it into a JavaScript object. And that JavaScript object we are going to give to this function. Then. We do this first, and then we do this. And then we do this. All right, what does this function do? This pulls from the response back from the server, different variables, and populates our weather object that we defined way up here with the things that we're interested in. The value of the temperature, so we subtract, this is going to return in Celsius. So if it returns 273, we subtract 273, we know it's 0 centigrade. We grab the description, we grab the first part of the first item in the description list, which is sub-zero. We get the first weather icon, we get the city and the country, and then we display weather. And all display weather does is it fills in those blanks using the values that we have just put in the weather object. There's a couple other things. If we click on the temperature, it converts it from centigrade to Fahrenheit, because we've calculated the temperature in centigrade by doing the conversion, because we're getting it back in Kelvin. All right, I'm going to do something right now that maybe, I hope, will make this, will clear up maybe some of the things that you're not sure. I'm actually going to output to the console the API call that we're going to make. And we're going to actually paste that into a browser window to show you that when we make this request, this is what we get back. So let me save this. Okay, we say, yeah, we want to see our location. It shows us the weather, which is the same as it was when we looked earlier. Now, if we look at the console, we see that little debugging code in here. and it shows the API call that was made. I'm going to copy that. And I'm going to paste that in the browser window, because this effectively is what our JavaScript is doing, is calling this URL. All right, but it's calling it within the JavaScript. We're going to take the data that the URL sends us, that the server sends us, and we're going to format it. So this is what we get. Coordinates, longitude, latitude, weather, ID of 804, that must mean something. The main weather tagline is clouds. The description is overcast clouds. The icon is this. Current temperature is 290 Celsius, which is about 17 degrees centigrade. It feels like 290. The low today is going to be 288, which is 15 Celsius. And the high is going to be 291 Kelvin, which is, doing all this math in my head, is that 18 Celsius? Yeah. Humidity, 85%, visibility, and all this. And then finally, it comes across with the name of the place and the location. So you can actually test, when you get to do your assignment, you can actually test your code. If you're not getting the right results or you're confused about something, you can test your code by pasting in the address bar of a browser the call that you're making to the server. All right, now, what is your assignment? This looks pretty good, right? Why mess with it? Well, I don't know, because it's fun. What you're going to do is you're going to change this. You're going to add, first of all, you're going to get rid of the geolocation. You're no longer going to pull the data from the browser's geolocation. So you can get rid of all the code relating to geolocation. Instead, you're going to have a text box and a button where the user types in the city they want. This is a nice little thing, but you know, it would be nice if you could check, you know, if I was going to Massachusetts today, if I was flying in, it would be nice if I could check what the weather in Boston is going to be when I get there. All right. So it'd be nice if I could type in the city instead of having it always pull the current location. So you're going to get rid of the geolocation code. You're going to put a text box in here where you can enter in the location that you want, a button that presses, and then it's going to call this. And it's going to display the weather for that. Now, what are you going to need to change? One thing that you're going to need to change is you're going to need to change the API call. Because the API call if you have the name of the city that you want is different. Remember, with the latitude and longitude, we have lat and lon on the query string. Here, we're going to have Q city equals and the name of the city and the app ID is the app key. We'll use the same app key. So we're going to just change this to just take a city instead of a latitude and longitude. So you're going to change where this call is made to be formatted, not to have latitude and longitude, but to have Q equals and fill in that value from a text box. part of your job is going to be to extract this. You don't need this anymore because you're not doing geolocation. Going to use this. So you can get rid of that function. You can get rid of the show air. You are going to call the get weather function, but it needs to pull the value from the form instead of getting the values passed in as latitude and longitude. This may sound intimidating, but if you understand what it's doing, it actually doesn't take a lot to convert this to work with city name instead of latitude and longitude. You're going to make a couple other changes. So you're going to remove the code that retrieves the weather data for a current location. Add a text box. When the user clicks a button, make the API call to retrieve the data for the entered data and display it. You are going to add the high and low to the displayed output. I'm going to add this here. When you click on any of the temps, then convert centigrade to Fahrenheit or Fahrenheit to centigrade. So if it's displaying Fahrenheit, you're going to convert it to centigrade. If it's displaying centigrade, and you'll do that for all the temperatures. So, how are you going to attack this? Well, my suggestion always for students is to do a little piece at a time. All right. I get the fact that you want to get this assignment done so you can go out and have fun, or go out and work on your other assignments, or do whatever other responsibilities you have in life. I get that. So you want to get through it as quick as possible. So you think by writing all the code all at once, if you get that code right, you're done. Well, it doesn't work like that. Trying to take that shortcut only is going to be a longer trip for you. I take flute lessons, and I will often try to do this if I'm learning a new piece. I'll try to play it from beginning to end, and I'll try to do that perfectly. And guess what? I don't play it perfectly. I have maybe a half dozen places that I'm having trouble with it. It's better for me instead to practice one piece of it at a time. That's manageable. That's better for your attitude, because if you get one part of it working, hey, at least I got that done. And it's beneficial because if you start to have a problem, then you know it's probably the most recent thing that you've added on. So do this a little bit at a time. These should actually be pretty easy. This isn't too bad, but I'd wait till the end to do that, because this has to work before this could possibly work. So I would wait till I had step 3 right before I worried about step 4. I will post the author's walkthrough of the code, simply because I don't expect you to understand everything from one lecture. Rewatch this lecture. Rewatch this lecture, watch the author's video. And I hope a combination of those will be enough to give you an understanding of what the code currently does, enough to allow you to make the modifications to do this. This is a very common thing, by the way, in coding. You know, programs, when they're written, they don't stay untouched. There's always a chance to take in and make enhancements to it or changes or whatever, you know. So therefore, this is a very common scenario that you have something that works and does its job, but you need to change it to do something else. Are there any questions? Yes. You want to type in the chat?
Yeah, let me put it in the chat here.
I think
Hold
we
on.
established I can't hear you.
Yep. Where's the chat? Oh, here it is.
Why is temperature.value.temperature 0 sub-zero value like the other ones? Because if we look, there's only one possible value for temperature. Other ones, weather, this contains an array of stuff. The array is designated by this square bracket. So weather has an array of stuff. I don't know when you have more than one entry in that array, maybe if the day was going to change drastically, like if a cold front was going to come through, maybe the first part of the day would be warm and then it would get cold, you know, at a certain time. But weather refers to an array, so we have to say which element that we want. And we can be sure there's going to be one element, so we ask for the 0th element. Temperature, on the other hand, doesn't have an array. It just has a single value, so we don't need to specify which one of the values. Anything else? This is an assignment that looks probably harder than it is. Again, the old cliche is anything is easy if you know how to do it, right? So it's easy for me to say that an assignment is easy, just as it's easy for your dentist to say this is not going to hurt very much, right? When it's you, it might be something else. But take the time to really understand what's going on first, and then the conversion added is actually not a lot of code. All right, that's all I had for today. We will either see you in lab or we will see you next week.